Bueno, buenos días.
Good morning. I'm Agustin Bilbao. Welcome to this presentation. Today is August 25, Tuesday. The next presentation is Harvest Seed Destroyer Basis and Operation. This will be a 20 minutes operation. Then we are having 20 minutes more for the Q&A session. So please, you can start writing your questions and to the right of the screen. All your questions are welcome. In the website of the Congress, if you click on the Aapresid logo, you can learn more about our contents. Also, there is a section called speakers. You will have the information about the speakers. If you want to follow us in the social media, it's hashtag Congreso Aapresid. John Inferrera is an specialist in Harrison seed destructor. This machine is used in Australia. It is a high adoption technology. It's ideal for weed control. He's member of the technical team of Mackinson Santan. They are authorized distributors of the Harrison seed destructor. John, please, the floor is yours.
Manager for the IHSD product, the integrated Harrington seed destructor, which is designed and developed in Western Australia over the past 25 years, looking at harvest weed seed management tools. Today we'll go through a bit of a presentation introducing you to the product, some advantages, and along with some harvest weed seed management information. Ray Harrington came up with this system in 1995. He decided that he was having some weed issues, and with resistance, the chemicals weren't working. So in 1995, he designed a mill. It was a toe behind the combine system. He worked on improving and running this unit over 15 to 20 years, and then in 2012, they became commercially available and were built by De Bruins in South Australia. In 2016, they started building them integrated into the machines that were hydraulically run. They had their own hydraulic pumps, and so they could run integrated with the machine. And then in 2018, a Western Australian farmer designed a mechanically driven mill that we are now commercially producing Australia-wide. And for the 2020 harvest in Australia, we'll produce 200 machines. It's two mechanically driven vertical cage mills that are retrofitted to the rear of the machine under the sieves. So we deal with the chaff that comes off the sieves, and that is processed through the mills that are spinning at 3,000 RPM. And when they go through the mills, they're severely impacted and no longer viable. All chaff and inert weeds are spread over the paddock as powder. As can be seen here, there is a bi-directional auger that feeds it into the mills on the left and right hand side, and then it feeds out of the external chutes and into the straw stream, driven on the side of the machine in conjunction with the chopper on a New Holland. Obviously we cover a few different makes and models of combines, but in this instance on the New Holland, it runs in conjunction with the chopper drive. As you can see here, there's a lot of chaff and dust that comes out. It's being processed and it mixes in with the straw that's going through the chopper. So as you can see in this picture that you're looking at now, we incorporate that back into the soil, eliminates any need for chaff burning and chaff lining. So as you can see, this is an integrated, neat little package on the back of the machine that kills 98% of the weeds that come off the chaff, off the sieves and through the chaff. It kills all of those. So, like I said, it destroys up to 99% of the weeds, weed seeds and volunteer grain that goes through the machine. It's been commercially built for over 8 years now, and it was originally a tow behind and now obviously integrated. It's a one-pass system, so there's no requirement for burning post-harvest to clean paddocks for chaff, and it's Australian designed and built after 25 years of research. As you can see here on a case machine, it's a similar setup. It comes out and mixes with the straw out of the spinners on the back of the case combine here. That's a 4-ton barley crop in Western Australia last year. It's a direct mechanical drive system. It mounts under the sieves and it is driven in conjunction with the chopper off the engine PTO drive. It's a very simple direct drive system with no gearboxes, no clutches, anything like that. So it just very, very basic design that is very, very effective. The bidirectional auger obviously feeds the chaff in, spinning at 3,000 RPM. Under the bidirectional auger in the middle there is a stone trap for any foreign materials that may pass through the combine, and so we don't ingest them in the mills. We also have the capacity to bypass the mills by disengaging the belt and opening the back doors, which allows us on the John Deere machines to feed the chaff directly into the choppers, and it still allows us to windrow. As you can see on the side there, we run off the slow speed chopper drive on a John Deere machine. It's idler pulleys and pulley drive pulleys driven direct off the engine in conjunction with the chopper. The bearings are over-specified for the job that they're doing. They can spin up to 4,000 RPM and run 300 horsepower through them. This machine takes about 60 horsepower. They constantly run at 3,000 RPM, which after all of the extensive testing that's been done over a number of years has been found to be the optimum number for the highest kill rate and lowest power draw on the engine. The patented IHSD mill technology is a cage mill that spins. There's a stationary cage and a moving cage, and it's just an impact mill, and it's built out of hardened steel. Very easy to deal with. There on the picture on the right, that's opening the stone trap, so any foreign materials can be let out. So it's a very simple system.
One of the key features of the new IHSD mills is our stone trap. As we all know, foreign objects will be put through the combine. Last year we had 2 retractables and numerous knife blades go through the machine. This particular machine, one morning when the operator was doing his pre-harvest inspection, he opened the door and this particular retractable finger was ejected onto the ground. The good thing was no damage whatsoever was done to the mills or any of the IHSD, and was able to keep harvesting.
Very simple bypass mechanism, so we can run the machine, we can run the combine without running the IHSD, or we can run the combine with running the IHSD and still straw, windrowing the straw. So it gives you some options. It reduces downtime in damp conditions, and it allows you to work in conjunction with your own farming systems. There's a little bit of footage here of both running in the northern wheat belt of Western Australia in the 2019 harvest on an S680 John Deere. So as you can see in that one there, he is windrowing his straw and still running his IHSD and processing the chaff and still getting a weed kill on the chaff, but windrowing the straw. And then in this one here, we're windrowing the chaff and still putting the straw through the chopper and getting coverage across the paddock to put back the nutrients in the residue. So after some extensive testing across the wheat belt of Western Australia mainly, as this is where the product was designed and built originally, we've done a lot of in-field testing, and as you can see, we did some tests with a demo machine with and without an IHSD fitted. So as you can see on germination on the left-hand side, that picture there is volunteer ryegrass in between the interrow with the wheat, and then on the right is cleaner. So the one on the left was running without an IHSD the harvest before, and the one on the right was harvesting with the IHSD. This is exactly the same position after harvest of the same paddock. In that field, we found the yields were less than half on that, which was a massive ryegrass issue in that field. As you can see, in 1 year, there was a difference there, and you can see that speaks volumes for the amount of weed seeds that have been processed and killed in that one spot in northern Western Australia. Some commonly asked questions that we have had over the journey with these machines is, firstly, does the IHSD affect combine capacity? An IHSD takes approximately 75 horsepower to run. So it runs at 60 horsepower empty, at full capacity is 75, and our clutch system is the belts, and they will begin to slip at 85 horsepower. So it does affect it to a degree. It probably brings the machine back about one class in combine. So if you're running a class 9 combine, it will bring it back to about the capacity of a class 8 if you are running that machine at 100% engine load. Have growers changed the way they use pre-emergent herbicides after they start using the IHSD? So this is some anecdotal evidence across our network that we've had for some guys that have been using for now up to 5 years. These guys they've said that they are still using their pre-emergent herbicides. We have eliminated some real problem areas in problem paddocks, but across the board, they are still using them as it's a tool in managing the ryegrass numbers mainly, but weed numbers. So what they have, anecdotally, what they have said is that their rates of pre-emergent chemicals haven't gone up over this period of time, and as a rule, they've sort of suggested that they do creep up over time. But since using the IHSD, they have held consistent rates of pre-emergent herbicides, and they're getting good results with these purely in the population numbers. So, and another question we get asked a lot is, if I spend money on the IHSD, will I save money on herbicides? The answer is, over the journey, over a long period of time, yes, that will be the case. First up, after the first season, the main saving that you will see is less population in crop, and post-harvest, the volunteer weeds and volunteer grain that does go through the machines, that is where we've seen the biggest saving in the shortest amount of time. In Australia at the moment, we've got an independent organisation called ARI, Australian Herbicide Resistance Initiative. These guys have put together an online calculator to calculate the cost of all harvest weed seed management tools that are being used across Australia at the moment. So there is obviously there's a lot of different options with chaff lining, chaff carts, chaff decks, bale direct, and a couple of mill designs that we're looking at in Australia at the moment. So these guys have put in all of the numbers. Our capital cost is higher than some of the cheaper ones, but as a cost of ownership for depreciation, everything taking into consideration, on an average season with the average crop in Western Australia, to run our machine is a $13.38 a hectare cost to own and run this machine, including the capital cost. And as you can see, there on the left-hand side, they've taken into consideration a number of things. Quite a cost-effective way of running any harvest weed seed management tools. We're pretty comfortable that this is probably a very good way to go, in the fact that mechanical destruction, we don't have to worry about the burning of fields and the issues that creates. At the moment, machines that we're fitting, we've gone back about 10 years, so we've got enough horsepower, and we've got the numbers for manufacturing. So in New Holland, as you can see, we go from the 80-90, 90-70, 90-80, 90-90, and then the DOT series. In the John Deere's, all S machines from S670 and above. In the case, all from the 7 series, from the 7230 up to the new 9250. And on the class machines, we've got the 8800, the 8900, and the 780 and 770 machines. On those, we figure that's the biggest population of machines that we have in Australia, which we're catering for. That concludes our presentation today. Thank you very much for joining us, and I hope you found the information informative and interesting. If you have any further questions in regard to any of the information that we went over today, please contact us via email, and we'll endeavour to get back to you with some informative answers. Thank you.
Bueno, Johnny, muchísimas gracias.
Johnny, thank you very much. We are receiving some questions. You are welcome to add questions because we have plenty of time. The first question is, did you see any difference in control and seed control depending on the wheat species and why?
Main weeds targeted in Australia at the moment are ryegrass. But what we have seen with brome grass and radish and wild oats is what we're dealing with here. What we've seen is if we can get into the crop early enough before they shed and get onto the ground, we're seeing very high rates of kill in all of those weeds. But what we're seeing is the ryegrass is our main target in Australia. Widespread testing has been done in regard to all sorts of weeds, black grass in Europe. So we're seeing some very high rates in all weeds. It's just a matter of timing before they shed and hit the ground.
Gracias. La otra pregunta.
The next question is, depending on the harvester's crop, is there any difference in control or in the kill rate?
Depending on the different type of machine, we're not seeing any difference from machine to machine. What we do process comes off the sieves, so that's where the testing's being done. What we can't manage is rotor loss that goes out through the straw, but from machine to machine, we haven't seen any difference. We are finding probably the best results in New Holland machines with the twin rotor, purely due to the twin rotor machines. They seem to get more weed seeds out in the processing through the combine.
Perfecto, buenísimo.
Thank you very much. If I can make a contribution, if I may, what we have seen in United States where they are conducting trials. In Australia, you are working a lot, but in US, there are some universities conducting trials. Amaranthus, which is one of the most problematic wheats in Argentina, has a high kill rate above 95%. This is what the HSD does, above 95% for Amaranthus pigweed. And the other question had to do with crops. You work mostly with barley and wheat and sometimes other winter crops. What about soybean that we work a lot? We have a lot of soybeans in Argentina.
Some testing has been done in the US on soybeans. There was some testing done in Arkansas last year. So with that, the golden rule with the soybeans was below 18% moisture. But there was some testing done in soybeans and the machine processed the soybean chaff with no problems at all. The other big crop in Australia is the canola or rapeseed. We've got very good results also in canola, and that's very widely grown in Australia, along with mainly barley and wheat. And then we are doing quite a lot of pulses, so lentils, chickpeas, faba beans, those type of things. So they are being processed through the machine as well. The problem that the pulses bring up is sand. There's a lot of soil goes through the machine, which is obviously very high wearing at the very high speeds that we're running.
Perfecto. Sí, eso con la soja seguramente.
Perfect. That would be the case with the soybean. What we plant here is sunflower and corn as well in Argentina. And as far as I understand, with the headers in that harvest, the HSD wouldn't be ideal for corn and sunflower.
Some testing that's been done in corn as the cobs stay in the rotor. It's not something that that has to be processed hugely, but we have seen there has been some testing done in the US on corn. With the current pandemic, we're not getting a lot of information out of the US at the moment.
Buenísimo. Nos están llegando.
Great. We are receiving lots of questions, so we have to be happy for that.
Algo que dice.
One of the questions is about the basis. If it destroys, does it destroy, or the principle of operation, does it destroy the seeds mechanically or with fans?
It is an impact mill, so it passes from the center of the mill out all the way out with 7 points of impact. There are some stationary bars inside the mill, and then intertwined with those is some bars that are moving at up to 1,000 kilometers an hour. So they are spinning at 3,000 revs per minute. So what we're seeing is as it travels through from the inside of the mill out, it's being impacted up to 7 times at a very, very high speed, and it's pulverizing the seed down to a non-viable state of it comes out like flour. So it just the impact of it is so intense and a number of times that it then renders the seed not viable just through pure impact.
Buenísimo, gracias.
Great. One more question: how long, how many working hours does the Destructor operates, and what are the advantages compared to other seed destroyers in the market? I mean, how long does it operate?
So we've seen an average with the mill life. So the mills are the wearing component. We've seen an average with those of approximately 400 rotor hours, so 400 hours of actually running material through them. And they slowly wear purely due to the fact that there's just so much material going through them. They don't lose any efficacy while they are running. So while they're wearing, they don't become any less effective. So we're seeing an average of about 400 hours, and there's continual improvement and testing being done on different materials to be used in the mills to try and extend their life and make them more cost effective. The biggest difference with the IHSD compared to the other machines in the market is we have a stone trap, and we run our mills vertically. So if a foreign object was to travel through your machine, any pieces of steel, they are ingested by the mills on the horizontal mills. With ours, that'll be caught in the stone trap. And the other one is they're positively fed, the mills are positively fed with the auger that's running it in. So it's actually pushing material in. If you get some green canola stalks, with a horizontal version, what we're seeing is some bridging across the very small hole to feed into the mill. With ours, it's on the side, and we're actually positively feeding the material into it, yet taking out any steel or any foreign objects, so they go into the stone trap. Because the retractable fingers off the front of the combine or anything out of the rotor, if they land on the sieves and go through, it could be catastrophic.
Gracias. Hay otra pregunta que es.
Thank you. This question has to do what is the state or the status of the wheats on harvesting. When the harvester passes through, the wheats pass through the seed destructor. What happens with wheats that had already experienced seed set? Do you think that we need to supplement this with to manage the situation with some other additional weed control tool?
Yes, so we're seeing all kinds of natural losses through the combine. So weeds that have already shed, rotor loss, which will go out through with your straw, out through your chopper. So what we are managing to kill a very, very high percentage of is what would be seen in a chaff line. So those numbers are the numbers that we're getting out of the crop. So it's part of a harvest weed seed management, but it's part of the weed management tool. So like I said in the presentation, it's part of a whole toolbox kit to run with your weeds. It won't eliminate your chemical completely, but it will lower numbers, and your population in the fields will actually lower purely through the fact that we're processing whatever we can get, we're processing. And obviously there will be some natural losses off the front through the machine, shedding, through the rotor. There's all of those different types of different losses all the way through. But with this, what the numbers we're processing is what would be commonly seen in a chaff line.
Perfecto, gracias.
Perfect. This question has to do with the size of the combines. There are some harvesters 40, 45 feet big harvesters that are using this technology. With that width of harvester, what are the yields you are working you are working now with? I'm referring to high wheat yields, and at what speed?
So what we're seeing in Australia in yield is anywhere very widespread, from 1.5 to say 8 tonne per hectare in wheat. And we're also seeing 60-foot fronts. So what we are seeing is the machines can process an amount of grain, and if the number is 40 tonne per hour, we're just going slower if the front is bigger. So we're seeing speeds anywhere from 4 to 12 kilometres per hour, depending on the size of the combine, the size of the crop, and the size of the header front.
Buenísimo, gracias. Siguen.
More questions keep coming, and the answers are very accurate. One of the question is there any effectiveness difference depending on the maturity of the wheat seed? Should it be dry, or when it is green, does it also destroy the weed?
So drier the better, I think, is where we've seen with the testing. In some softer, greener ryegrass, there is still a very high kill rate. It might drop back to, I think the number's 93 or 94%. What we're seeing is the sap, anything coming out with that impact. It's not a shearing motion, it's actually just an impact motion, and it is still rendering the seed non-viable, and the moisture's coming out of it at that point as well. But we want to get it when it's dry, but we also want to get it before it sheds. So there's probably that optimum window of harvest in the middle of that point in time that everyone wants to harvest at the optimum time, and there's obviously time constraints in that. But yeah, we are seeing kill rates in green ryegrass as well.
Gracias. Hay otra que a mí me encanta.
There is another one I love. Have you assessed the savings when you add up the seed destroyer plus targeted applications? That is, weeded or weed seeker. Have you assessed the addition of those two technologies? Peter Newman yesterday talked a little bit about this. Maybe I can talk about that after you answer my question.
In conjunction with in-crop spraying. So what we're seeing is in-crop spraying is one tool to lower some numbers. I don't know what the numbers are like. So we're getting some in-crop spraying with targeted chemicals. We're seeing some with pre-emergent chemicals. So obviously pre-seeding and at the time of seeding, we're seeing some numbers drop. Then at harvest, this is another a line in the defensiveness of killing the weeds. It's just every time that something goes through, I suppose every time there's a pass over the crop at this point in time where we're killing some more numbers, and it is just to lower the whole population in the field rather than just trying to get them in crop or pre-emergent. This is just at another time of the year where there's no extra time taken because we're already harvesting the crop anyway. So it's just another tool that is integrated with another job to lower our overall population over a long period of time.
Buenísimo.
Great, thank you. If I may, Peter Newman yesterday talked about something similar, a similar topic, and in the cases when they have added up things, he didn't talk specifically about the Harrington, but about the chaff lining. That is, the lining of chaff. And instead of having a destroyer doing targeted applications. So he saw that on the surface area, you're applying between 10 and 12% of the total surface area with weed-in and weed seeker on the chaff. In the case of the seed destroyer, it would make no sense because most of those seeds would already be destroyed, right?
Yes, so what we're seeing is in the chaff lines that Peter Newman is referring to, where you can target your chemical into those lines. What we're seeing in the seed destructor is we are killing a very high percentage of those, in the high 90s% of those weeds, whether they be volunteer wheat, barley, or canola, or soybeans, corn, or ryegrass, annual ryegrass, radish. So we're killing those in that pass rather than going back. What we're also doing is redistributing the nutrients across the soil. What we're doing with chaff lining is it's very targeted in a very small, maybe 300 millimeters, 400 millimeter wide chaff line. You're targeting a lot of nutrients back into the soil and landing a lot of carbon in one spot. What we're looking to do is spread evenly across the field. So there's advantages, and like I said, there's a lot of tools across the board. We think this one is fairly, it's cost effective, and also saves with the chemical, even with targeted spraying, saves going back with that. And then obviously the chaff line burning so we can crop next year and we don't have the built up straw in those lines.
Perfecto, gracias.
Great, thank you. Well, you've already answered another question that I have here about the concentration of stubble in a line. Would that go against a good distribution? It's important to take into account the percentage of chaff in the total stubble volume. So that is a question we may ask to understand that it is not so important to concentrate a part of it, because actually it's only chaff and the rest is distributed all over.
Right, so the straw is distributed. I think chaff is approximately, I think it's 20% of the total out of the back is being distributed as chaff and 80% as straw. So what we're seeing is that small 20% in a chaff line is very concentrated and obviously needs to be managed so that the next year's crop can get through it as well. So by spreading it evenly, we're getting 100% back out across the field and distributed very evenly for putting the nutrients back in, which is actually in that there's a dollar figure on the little thing in the presentation. They've actually put a dollar figure on what the nutrients is worth as we're spreading back rather than concentrating into the chaff line.
Gracias.
Thank you. The Harrington Seaweed Destroyer, do they always work with a combine, or in some cases do they take it out of the destroyer? I mean, do they take it off the combine?
We're leaving it on all of the time. In some fields where they've had a good desiccation rate and killed the ryegrass prior to harvest, they are running everything through to save on mill wear. They are running it into a chaff line or spreading it out so that they don't have to process through the mills on, say, in some pulses if they've had a desiccation kill of ryegrass, or in some very, very clean paddocks. Some farmers in Australia are bypassing to save the additional cost of running with mill wear and the extra horsepower.
Thank you. How do you see the situation of weeds in Australia from here to the next 10 years, by 2030? How do you see the weed situation in Australia?
Australia's got the poorest soils and a very low rainfall. So what we have seen over a very long period of time is ryegrass has not been. Everybody's battling with ryegrass at the moment. So ryegrass is our main one across Australia. So we've seen areas for a very long time have the issues, and they're slowly getting further and further afield with the different cropping methods that are being undertaken. Some areas in Australia were very heavily stocked areas with sheep and cattle, and they have now become cropping areas. So those weeds haven't had as long with chemicals, but what we've seen is for a very long period of time resistance. We are now seeing heavy resistance to most chemicals, and with Roundup becoming less effective, we think that this is one of the tools that will help, I suppose, get the population down. But we're really struggling with chemicals here at the moment, and there's also a bit of a movement away from chemicals as well. Guys have with the Roundup side of things that's happening around the world. Some guys are looking to move away to a degree, but we can't. That's not viable at this point in time either. So we think over the next 10 or 20 years, I think the only thing we could hope is chemicals get cheaper is probably so then our rates can go up to keep managing at this point, but they're not getting any better.
Bueno, muchas gracias. Ahí en ese...
Thank you. I don't know whether you're aware of this, but in Argentina, we're having trouble with how society looks at the farmers, and these tools will be very important for us. In our area, for example, there are some areas where we cannot do any kind of agrochemical applications 1 kilometer away from populations. And this is bringing about lots of issues. These tools will be key to replace agrochemicals and turn to other complementary management tools like cover crops, agrochemicals, and Aapresid has been working on this for many years, and we're doing very good things.
We are seeing similar things in Australia with the way the community is viewing farming. Our advantage possibly over Argentina is a very large land area with a very small population. So we don't have too many areas of agriculture very close to large populations. So that is something that has maybe assisted us in Australia more so than Argentina. But yes, no, we are seeing the same issues here in that regard.
Well, thank you. There's a question about the costs. Can you please remind us what the cost of this technology is and the annual maintenance cost as well in dollars?
In US dollars at the moment in Australia, these are being retailed at about 70,000 US dollars a machine. To be fitted onto the back is about, it'll be 70,000 US. And then the running cost of the machine, as we've had them in the field for 2 years, the only things we've seen are a very low value belt that runs the machine and the wearing of the mills. The mills, a complete set of mills is costing about 7,000 US dollars for a complete set of mills and takes about 3 hours to change. So those mills are lasting about 400 hours. So we're maybe $1.80 at 10 hectares an hour. We're at about $1.80 a hectare in cost to run those at those type of numbers.
Great, thank you. Well, we have received lots of questions and we have received the answers as well. It's been great. We have a few minutes left. And if I may, I can tell you a little bit about our vision. Aapresid, CREA, many Argentinian organizations have been working on weed management alternative tools. So my final thoughts are that we cannot do away with this tool in Argentina. We are a bit behind in this respect. What we do have to study is the different areas we need field work. In the US, this is being studied in soybean, as you said. But as far as I know, there are some areas where soybean is harvested when it's greener, and if it's greener, this is more difficult for seed destroyers. In other areas, it's harvested when it's drier, and that's better for pigweed. As we said, it's working very well. Ryegrass and pigweed are major threats in Argentina today, and apparently it works very well with those two weeds. But we should first understand under what circumstances it's going to work and under what circumstances it's not going to work. We need more studying in that respect. And this technology can be added up to agroecology. That's when agrochemicals are not used, as you may know. And it's still very important for this technology to supplement the other tools, because if we only use this tool, then the early seeds will move forward and we will have weeds that will be resistant to the seed destroyer. If you'd like to add some final thoughts, and then we will have to close.
Absolutely. So, I suppose gene selection, like you say, the very small weeds are the ones that take all of the nutrients and still cost you yield. In regard to the very green soybeans, the issue we are working with the manufacturers now in R&D to make a mill that can handle greener material. We did some testing in April this year with lucerne in South Australia, which is a little bit greener when it's harvested. The issue with green material is water cannot be compressed. So if it's full, it's full. When it's very dry, it can be compressed and managed very well. When it's greener, it is a lot harder to deal with and process. So there are things happening in R&D at the moment that they are looking at managing the higher moisture crops of Europe and the States and South America. So they are working to see if they can actually process some of the much higher, like 20% grain, 20% moisture grain type of crops. But yes, there'll be the natural selection of the early shedding weeds, maybe the shorter weeds. But yeah, look, this is just, like I said, a tool that is getting some of the population in a one-pass system. So we can only hope for the best, and the war continues.
Bueno, entonces, Johnny, para finalizar,
Johnny, to finish, we are going to challenge the Argentine farming sector to use this joint, to add this tool to the ones we are already using. Our motto this year is always green. That's why I think that we should continue to use it. We hope to see you in person sometime. Thank you. Me encantaría ir a Argentina, sería fantástico. Probably we will be able to do that in a short time. Esperemos. Por ahora no. Thank you. I want to thank all the participants for being here.